everyone, and thank you for joining us today for our webinar on the proper use of shackles. My name is Gisela Clark. I'm the social media specialist at Columbus McKinnon, and will be your host today for our webinar. Today's webinar on shackles is part 2 of a 3-part rigging series. Today you will learn how to properly inspect, select, and use shackles. Presenting today will be Peter Cook, our training manager. He specializes in rigging and load securement. Peter has been dedicated 15 years to Columbus McKinnon as an engineer, designing engineers' lifts, slings, and forgings. He's traveled throughout the world teaching proper rigging techniques, rigging gear inspection, and hoisting crane inspection and maintenance. Also on the call today is Travis Cobb. He's a design engineer from our CM Forge operations, and he'll be assisting Peter with questions at the end of our session today. A few quick points excuse me, before we get started. As I said, we are recording the session today, and the recording link will be provided on our YouTube channel, as well as being emailed to everyone who registered and or attended. Everyone has been muted, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes of questions at the end of our session, and those that don't get answered, we will personally respond back to within 24 hours after our webinar. Thank you for your attention, and now I'll turn the meeting over to Peter so we can begin.
All right, thank you everybody for attending, and we'll get started. And today's topics we'll try to get through to in the next 45 minutes is define shackle types and configurations, shackle identification and markings, shackle inspection, safe rigging practices with shackles, and then we'll just take some general questions that you have at the end. So just to start, all CM shackles are made from specialty bar quality material and comply with ASTM A322, ASTM A576, or ASTM A921. And we also meet U.S. government specifications RRC 271, ASME B30.26, the EN standards, ISO, DNV type. Galvanized shackles meet ASTM A153 and B675, and pins and bolts meet SAE J429 and ASTM A354. So a lot of quality goes into our shackles, and we do extensive testing on them to be sure that they're safe to use out in our marketplace. So let's start. We have different types of shackles, and just to quickly go over those, we have the screw pin anchor shackle, as you can see. Just has a screw pin. There's no bolt and nut at the end. The actual threaded goes into the body of the shackle, and that's usually the rigger favorite because it can easily be unassembled and reattached easily in the field. We have the bolt nut cotter style, which is it does have the bolt nut and cotter, as you can see there. And then we have the chain shackle or the D shackle, which is a smaller type shackle and more compact, and we'll get into those as well and how those are used. So let's start off. When do we use a screw pin anchor shackle? Again, it's for easy removal. It's usually the rigger's favorite. You don't have to have any tools with you out in the field. It does have a hole in the pin head there, and that is for a spanner wrench. So in the event it does get a little locked up, that you can put your spanner in there and undo the pin. But where it's going to be a semi-permanent connection, these are more for temporary connections, but it's semi-permanent connection, it's a permanent connection, we want to move to the bolt nut cotter type. This way we know it's secured on the load. You must have that cotter pin in place as well to prevent the bolt from backing off. So if you're going to leave this on a piece of equipment or leave it where you're always going to be connecting to it, where you don't want to keep taking the shackle on and off, this is what we recommend that you use. Both the same shackle body, it's just the pin design is a little bit different. When you want a smaller, more compact shackle, then we use what we know as the D shackle, or we call them chain shackles, and they're more for direct inline loading or where you need a smaller body shape, and that's where we recommend these type of shackles. But its applications are similar. Okay. Okay, and then this shackle here is called a round pin shackle. Okay, this has no threaded connections at all, and this is more of our load securement or towing applications, tensioning, things of that nature. there's no threaded connection. There's no threads within the body of the shackle or on the pin. It just has a cotter key going through it. It's really not recognized by ASME B30.26, and so we do not recommend this shackle for overhead lifting. We feel that the threaded connection shackles are their best bet for overhead lifting. In the event you were to lift something and something were to strike that pin, all you have is a cotter key holding that in place. And so we steer people towards the threaded connected type of shackle. Okay. With that said, shackles are made from three material types: carbon, supercarbon, which is specific to CM only shackles, and then we have alloy shackles. All have different working load limits, and all can be used for overhead lifting. Some of the confusion that we get, because we are a chain manufacturer, in the chain industry we can only use alloy chain for overhead lifting. Well, shackles are not chain. You are allowed to use carbon, supercarbon, or alloy. It's whatever your preference or the application that you're going to apply that shackle to is how you choose that. And we'll go over a little bit about pros and cons of using each of those, okay? But however, with that in mind, that we have three different materials, we never want to go by the diameter of the shackle as to, okay, we have all 1-inch shackles or 7/8 shackles. They must all be the same working load limit. We need to look at the embossings on the shackle to identify the working limit, because you are going to have different working load limits with the same diameter size, given that there are different materials that they're made from. So here's a side-by-side chart showing the different types of materials that shackles can be made out of. And let's just take 1/2 inch, so you can see in the carbon. Let me highlight that for you. But in the carbon here, 1/2 inch is good for 2 ton, supercarbon is good for 3 ton, and the alloy shackle good for 3.3 ton. And we look at the design factors. Carbon shackle that we manufacture is a 5-to-1. The supercarbon, we actually have a 6-to-1 design factor, and our alloy is a 5-to-1 design factor. Okay, so the big difference between them, and you want to start looking at markings. And markings are huge today. Understanding what those markings mean and why we put them on there, and it just ensures quality inspections, safety, and that the riggers are using safe equipment and can identify their equipment properly. So when do I want a supercarbon versus a carbon? If you're just, nothing special and just general type of lifting, I'm sure carbon will be fine. If you need a higher working load limit with the same size shackle, then you want to move up to the supercarbon. Hey, I can't use that larger shackle because it maybe not fit properly, but I need a higher working limit. And then you step up to the supercarbon. Again, you can go to a small, or vice versa. We need something smaller. You can go to the supercarbon instead of going to the next higher carbon size. A higher working load limit without the expensive alloy, because alloy shackles are a little bit more expensive. So if you want to save a few dollars, stick with the supercarbon. Anytime the user isn't required by ethics to use something else, we recommend supercarbon. And again, a higher safety factor. Alloy shackles, when you need an RRC rated, that's a government rated shackle, which meets certain quality standards. So there'll be military specs and things of that out there that require government rated shackles. So we'll have those for you. When you need increased toughness, now toughness is a combination of strength and ductility. So alloy it probably has the best toughness around. So in cold weather applications, that will hold up a lot better, and it also resist shock loading. And I'll have a few slides showing that coming up. Alloy bolt nut cotter shackles are 100% proof tested. Again, higher working load limits, but need the same shackle size, or you need a smaller shackle with higher working load limits. Then you go to the alloy. So all depends your applications, how things fit, and what environment you're putting it in, why you would choose one over the other. So here we have a comparison of our supercarbon versus just a regular carbon shackle, just to show out there. And again, CM is the only one that has supercarbon shackles. And again, this is the what is called toughness, and toughness relates to strength of the shackle. And really, it's a combination of strength and ductility. And so what it results is it's very resistant to shock loading, so it holds up a lot better. And we have a video on our blog, and I'll show you how to get to that blog, where you can watch a video of the super strong shackle being compared to a carbon in a shock loading test. But, of course, we do want to avoid shock loading. I do want to mention that, but we realize that things happen out in the field, so the more safety you can have where it does happen, that it will, try to prevent any type of failure. Shackle identification and marking. So what do all these markings on this shackle mean? And that's important as a rigger. The very first thing you need to do as a rigger is inspect that shackle. What's the markings on there? Who is it made from? Is it the right size that you need? And CM right now is coming out with enhanced identification markings. The forged identification markings on the shackles will be the largest and the most user-friendly on the market. The larger, the more legible it will become. Improves operator safety by reducing the risk of users misreading or unable to read important size and workload information. Reduces replacement costs by decreasing the necessary of out-of-service issues due to worn or illegible markings, because if it's not marked and you can't read it, you have to take it out of service. So you'll have a longer life of using the shackle. So it makes it easy to identify as a CM shackle that it's a good quality shackle. And so what is required by ASME, the industry standard B30.26, name or trademark of the manufacturer, and you can see in number 1 there, the CM logo. You should know who it's made from, a reputable manufacturer. I've seen shackles out there that say China, and that's it. I'm sure China is not the manufacturer of that shackle, so who do you go to when you need technical information or something happens? Who's that person you talk to when you're in that bind? Okay, we spend thousands and thousands of dollars on our rigging, mobile cranes, hoisting equipment, and the shackle is just as important. It may be not as expensive, but it is part of the lifting system, and so why would you skimp when it comes down to the lift point or the shackle? Number 2, the rated load. Of course, that needs to be on there, how much it can lift, and the size and the diameter of the body, which also will be stamped. And then we also have a trace code, which internal to CM is a 3-digit trace code, so it means something to us. So if there was a problem, we can get those trace codes and track it back. Also, what's new now is a raised surface that a lot of customers are requesting to put serial numbers on shackles, so now they will have the ability to serialize their shackles for inspection purposes and quality, and to be sure that rigger has a good shackle in service. But even the pins are marked. So how do you know if the pin is the right pin? Well, the pin has to have the manufacturer logo, as you can see here. Okay, it has to have HS, which stands for high strength, and also a trace code on the pin. Now that's important because we have 3 different types of shackles, right? So what if the pins got mixed up? Well, how do I know what was on the alloy, or how do I know what was for the supercarbon or the carbon? Well, in this case, it doesn't matter. All our pins are high strength. So we designed the same pins for all our shackles as far as size for size, so that if at the end of the day you had 3 1-inch shackles, all of different material, let's say you had a carbon, a supercarbon, and an alloy, and those pins got mixed up, that it wouldn't matter, because the CM has all the same pins, that you don't have to worry about strength level of the pins. All the strength level of the pins are the same. But even the pins are marked. So start out. That means something, right? So that now you know that that pin is a quality pin and it's not an aftermarket or someone just threw something in there. So all those markings mean something. And so here you can see CM, which is, of course, Columbus McKinnon, has a trace code, and HS for high strength. Okay. Again, that's important. I know the forging plant right now is changing the styles of their pins so they're more efficient. They thread in, fit easier, great connections. So they're working hard to make it more user-friendly and have great engagement at all times throughout the manufacturing process, and to get out into the field so that it's a good quality shackle. And I'm very impressed with the shackles that CM is coming out today. I think they're one of the best in the industry, and just all in all, a very impressive shackle compared to 5-6 years ago. I think it doesn't even compare. They're I think right now the best looking shackles and quality shackles on the market. All right, inspection criteria. So now we got through what all those marking means. We chose the right shackle, but now we want to be sure it's safe to use. So that's our next step as a rigger, and so we want to go through and inspect it before we use it. So a visual inspection shall be performed, and where it's in a location where you can't get to, or it's not feasible to inspect every lift. You have to at least do a periodic inspection on those shackles. So at least once a year you should be looking at that, or more, depending on the severity of service. So it might be 3-4 times a year. But in reality, if you're applying the shackle for a rig, it's not a big deal to inspect it. You should be inspecting it and being sure it's safe to lift. So what is a periodic inspection? It's a complete inspection of the shackle shall be performed by a designated person and not to exceed 1 year, but written records are not required. I teach people in our training, just look it over when and all your rigging equipment, when you use it as best you can, do a frequent inspection, look it over, be sure it's safe to use, understand what you're looking at. You're just going to make a more safe lift. And so what are the rejection criteria? So we're looking for wear, any part more than 10% of the original dimension, any type of distortion, twisting, stretch, elongation, cracked, or broken components. When if you're in doubt, take it out of service. Look for excessive pitting, corrosion, indications of heat damage. The markings all have to be there. If you can't read the markings or you're not sure what is that a 1 ton or a 1.5 ton, it's got to come out of service. You don't take the guesswork right out of it and remove it. Look for body spread. You'll know that, especially in a screw pin, because it'll be very tough to thread in. So the bolt nut cotter, may not line up. Probably will be tough to get the pin out. Look for makeshift pins. Now that you all know what the pins look like, you can look for substandard pins. And then also any field modifications, any type of welding or someone did something they weren't supposed to the shackle that causes you concern, take it out of service. Again, if it was designed to have a cotter pin, it must be there in place and in good working condition. So if you have a bolt nut cotter type and you're missing the cotter, you need to get a cotter in there before you use it for rigging. And just some pictures of things that we find during our inspections. Common in shackles, people like to grind the eyes because they don't fit properly, and instead of getting the neck size up, they'll grind the eyes to make it fit. So that's not good. Believe me, we have enough material in there to hold a load, and by removing material, you're creating stress risers, and it's who knows what it's good for at this point. Again, substandard pins, cracks, elongated eyes, those will start to get worn over time, so we need to be aware of that as a rigger. Again, just certain things we found, grinding and wear over, the shackle off to the left, overload, just extreme deformation there. Get it out of service. Anytime you suspect it, you overloaded it, or someone has overloaded it, take it out of service. So all right, so now we've selected our shackle, we've inspected it, and our next step would be to rig with it. So how do we rig proper with it? All right. So usually, why do rigging accidents happen? We either select the wrong gear, gear's worn, it's used incorrectly, or the operator's not trained. So things like that in those pictures should never happen. And if I'm doing an inspection for somebody and I find rigging equipment like this, I know that their riggers or their operators need to be trained properly because they're doing something wrong, or they selected something wrong and the application is the wrong fit for whatever they're using. So as with any rigging operation, no matter what you're choosing, whether it's shackles or swivel hoist rings, chains, synthetics, wire ropes, you need to know how much weight you're lifting, where your center of gravity is, the number of attachment points, angle of loading, the share of load on those points, and the conditions that you're working in. Excuse me. Shackles can be used from 400 degrees Fahrenheit down to -40 degrees Fahrenheit, and if you go any temperatures beyond those, contact the manufacturer of the shackle to see what the rating would be used in those environments. Screw pin shackles are great to be used as a gathering ring, so we're going to connect multiple slings to it. In the entertainment industry, that's common, where they have drops and they connect various slings to it to get their points. And we do it in construction for synthetic slings, to connect synthetic slings to make a bridle assembly. And so that's what another use of a shackle, not only as a lift point on a load, but also as a gathering point for slings. But we want to avoid bunching on the slings. D-shaped shackles, as we mentioned before, are more for inline loading, and we really don't want to see side loading on D-shaped shackles. So are great. They're nice and compact and easy to use for tight spaces, but you really want to use those for straight pulls. You don't want to have a shackle orientate itself in the wrong orientation. Everything you try to remain everything in line. So that will weaken and damage the shackle. Eye bolts are always used incorrectly. Many times they're not, in this picture here, you see the eye bolts aren't lined up properly, and they're directly connecting a hook into the eye bolt, which is going to create a side load on those. So it's a very dangerous situation because they could snap off. So if you're going to connect any type of eye bolt connection, you want to throw a shackle in there first and then connect to your hook. Be sure that you're using the correct eye bolts. They're seated properly and in line with your sling tension. And then that's a proper application. And always take your reductions when you're looking at angles. Again, that's something we teach in our rigging seminars, how to take reductions versus angles on eye bolts and other rigging equipment. So there's many ways to connect in different uses of a shackle. Here we see a chain loop through a shackle, which a lot of people will do. And then we have to worry about the D-to-D, or we can do that with a wire rope. Again, we have to worry about D-to-D reductions. We'll talk about that. Directly connect with a hook, which is fine. As long as it's in line, you will get the full rating of the shackle. Choking a synthetic in any eye, whether it be an eye bolt or an eye of a hook, is a very bad practice. It's like tying a knot in a sling, and so you're going to have a failure when you do that. So that's not correct. You want to throw a shackle in there, and you can see the next picture. Well, that's the way to do it. And you have to have full width. You get full width of the sling in the way it was intended to design. To get full work and no limit. Okay. When connecting to pad eyes, you want to make sure that the pad eye is 50 to 80% of the shackle width. We recommend that a qualified engineer look at those pad eyes and calculate it for strength and shear and things of that nature. I always caution people, just don't connect the shackle to a hole. Some welder blew through a piece of plate and made an eye. That happens all the time. It is a lift point. Again, we spent thousands and thousands of dollars on the lifting equipment from top to bottom, and yet we're going to connect to some piece of plate that somebody blew a hole through with their welding machine on some minimal plate, and we can lose the load that way. So why would you spend all that money on the quality equipment that you have to lift safely, and then you're really not going to worry about the lift point that you're lifting from? And that's common, and it's just kind of a backwards type of thinking. That it will be safe to do, and so it's always your weakest point in the lift that's going to fail. And lift points are one, so you always want an engineer to design a lift point. And to right now, there really isn't any standard on lift points other than get somebody that's qualified that can calculate the shear strength of that steel. When lifting with shackles, if you're going to connect two shackles together, we recommend bow to bow or bow to pin. Point loading of shackles. Try to use the same size or larger diameters when connecting to the shackle. Avoid point loading of sharp edges. Obviously, that's going to damage the shackle. And try to stay in line as best as you can. Don't loop slings through the eye of the shackle or on the pin, because that can loosen up the pin. And also, it's a very unstable load by doing that. There's, if you have an offset center of gravity, you're not going to have much load control. So really, we don't recommend that type of rigging practice. So the correct way is there's the proper connection. We always say bow to sling when you can, and then you would connect your hook into the pin style. But avoid bunching. Avoid too many legs, multiple legs. Again, don't try to shove everything into one shackle. Use multiple shackles if you can. You may even have a oblong link, or what we call a master link, that you can connect the shackle pins to, and basically you're making a bridle assembly by doing that. So various ways to do that. Just as a food for thought, when you're connecting bridle assemblies, when you do it to a hook, you only have a maximum include angle of 90 degrees. If you go beyond that, you can tip load the hook or pull the hook out. And so a master link gives you 120, and a shackle also gives you 120. So another reason you may want to throw a shackle over a hook. A master link is kind of limiting because it's tough to connect other slings to. So, but a combination of an oblong link or master link and shackles. Basically, if your rigging doesn't look clean, it's probably wrong. It's probably bunched up. So you want to get nice, clean look to your rigging and your connections. And if it doesn't look real clean, you probably have incorrectly sized everything. So you want everything to lay proper and in the right orientation. And when that happens, and if you selected everything right, you shouldn't have a problem. When doing chokes, the bow of the shackle should be put into the butt of the choke and not the running part of the choke. So in that picture, that's the correct way. That's a double wrap choke on a loose bundle, and that's highly recommended to do it to have control. Anytime you are lifting loose bundles, by the way, you're going to want to have 2 points of connection. So in this case, I would want 2 slings and 2 double wrap chokes coming in on that. And that would be not. I would never want to do a single pick on a loose bundle or what's called a below a center of gravity lift. However, there you can see the bow is in the butt of the shackle. That kind of reduces friction a lot, and also you're not putting the pin in there, which can loosen the pin. Side loading of shackles, and this is CM has produced this for years. This is now in the ASME B3026 spec, and your reduction for side loading. So if the angle 0 to 5 degrees and in line, you're going to get 100%. From 6 degrees to 45 degrees, you're going to get 30% of load, and then 46 to 9 degrees, 50%. And again, this is symmetrical loading. Obviously, if you have unsymmetrical loading, you're going to have to figure out your share of load. And once again, we caution against using round pin shackles. Those are the shackles that do not have any type of threaded connection. They're just a cotter pin retainer. We highly recommend that you don't use those for overhead lifting. Keep those for tensioning or securement and towing. So again, off-center lifts, you can see here shackles can twist. I had another slide showing that where it was a full side load, but we really want to avoid that. So we try to get it in line as best you can, and if you can't, take your proper reductions, be on the safe side, and reduce the reduction a little bit, or excuse me, reduce the working load some based on the charts that we just showed you, or call your manufacturer of the shackle and get that information from them. You can recenter it, or some people have used washers or bushings or things of that nature to try to keep it centered. If that's not practical, then take your reductions. D to D ratios. So if you're going to use a wire rope, let's say you loop it through a shackle, and that D there is, let's just say, the body of the shackle. Well, if you have too small of a diameter, really you should be matching the shackle diameter with the same size of the rope diameter. And again, if you can't, then you're still going to start losing work limit. But in this case, this shows a basket sling, and in the basket sling here, really to use a basket sling, we would have to have at least 25 to 1, in this case 30 to 1 times the diameter. So big D has to be 25 to 30 times bigger than the diameter of the wire rope. If we don't achieve that, we're going to distort that wire rope, and it's going to damage it, which means it was misapplied. And so we have to pay attention to D to D ratios. If the shackle is going in the eye of the sling, then we want to match the diameter of the wire rope to the diameter of at least to the diameter shackle right in here. Basically, the eye is a basket, and so we want to match the diameter of the shackle to the wire rope size. Get to the next slide here. So here are various configurations. The one I just showed you, then the shackle in the eye, and then one looping through. Each case, you get different work depending on your D to D. You can get different working load limits. All may seem like the same connection, but they're not. And so again, pay attention to your D to D when you're lifting. Chain also has a D to D. Not as much as the wire rope. You only need a 6 to 1 for chain. And so if you're looping chain through a shackle, the diameter of the chain needs to be at least 6 times larger than the shackle that it's going around, so that we don't damage it. And there are D to D charts, and that's published in the NECM. It's also published on our blog site, which I'll show you how to get to as well. So here I'm at my half-hour mark here, and we're going to at least spend 10 minutes for questions. It's a 45-minute seminar. Just want to make note, if you're interested in any type of rigging training, that's just a very quick overview of shackle inspections. We do have another seminar coming up called Rigging with Lever Tools. And so we'll go over inspection of a lever tool and how to use lever tools properly for lifting and for tensioning. And that's going to be on June 6th at the same time, 11 to 11:45. And if you want to learn how to become a qualified rigger, we have qualified rigger workshops, rigging gear inspection workshops. It's a full week for the qualified rigger, excuse me, and we go over quite a bit of information. We test you, and we also have the ability to offer a certification test if you want to become a qualified rigger. We have a hands-on facility in Tonawanda, New York, again, it's between Buffalo and Niagara Falls, where we have 2 overhead crane systems. We lift all types of loads, plates, structures, a variety of slings, and it really goes through the gamut of rigging, and truly gives everyone that takes the course, it's an eye-opener for them of what rigging is all about. And everybody that takes it, I thought I knew about rigging until after the workshop, and now I'm fairly confident I know what I'm doing. So that we offer that type of training for you guys. We're also involved in workshops throughout Canada, and this one we're attending in Edmonton is June 17th through 19th. It's the ITI Heavy Lifting Workshop. And then we have also in Houston, API Offshore Lifting Conference and Exhibition, July 16th to the 17th, where we're present there as well. And our people are more than happy to answer any questions for you at any of these events.
Well, Peter, a few questions have come in.
Yes, please.
One of them, I think, was about 20 minutes into the presentation. It was from Steve, and he was asking about the moment. Wouldn't the moment be the same? And I actually probably should have jumped in and intervened then. Steve, if you'd like to elaborate on your question a little more, we can address that. Unless, Peter, you remember what he was referring to when he asked it?
Yeah, he's probably talking about the moment arm or something in bending.
Actually, he said it was the hook shackle issue. On the hook shackle issue, wouldn't the moment be the same?
The hook? Oh, you're talking about
if
he's talking about the included angle from 45. That we have the 90-degree included angle, and then we also have the 120 included angle. Okay. If that's what he's talking about.
Excuse me. Here's what he's saying. He said it should be a hoist ring rather than an eye bolt.
Hoist ring is much better than an eye bolt, absolutely. However, eye bolts are also used for attachment points. They're readily available in the industry, and I agree 100% that I would prefer a hoist ring over an eye bolt. However, the eye bolts are used for lifting, and you really need to know what you're doing when lifting an eye bolt. Lifting by an eye bolt, any wrong move, or you're not assembled properly, or you're not taking your reductions could result in a failure.
Okay.
Where swivel hoist rings are much more forgiving. They stay in line. They're just a much more safe product to use.
And if we're pulling it off of a vertical 10-4, or maybe, I'll tell you what, we'll get back to that question. Okay. We will address a few others. All right. Is there a proper way to secure a screw pin so it doesn't vibrate loose?
Yes. What's called a mouse. What you want to do is you want to make sure you fully seat that screw pin, okay, as you normally would apply it, okay, and that you make sure that it's fully seated. And then what you do is you want to what's called a mouse tail. You want to tie. There's that hole in the shackle, and so you want to take a piece of wire and tie it back to the body of the shackle.
Okay.
And if that's a big concern, you might want to go to the bolt. That's where it may be an application as well that you may want to go to the bolt nut cotter.
Okay, great. Great. We have another question that came in, and this was actually posed by Brian on a LinkedIn page, LinkedIn group. But his question is, will we be offering ETCP renewal points for upcoming sessions?
It's something we can right now. We haven't looked into that for our webinars, and it is something we will look into. And if the more we can offer and provide our customers with continuing education credits, for those of you, ETCP is the rigging certification for the entertainment industry, and they get continuing education credits by attending schools and things of that nature to keep up their certification. So. In the entertainment industry, the more training they attend, the more points they get to uphold their certification, which is a good thing for them. So anytime we're bringing our families to concerts and Disney on Ice or theaters and things like that, that rigging equipment that's all over the place is safe and by ETCP professionals. So we may not be directly involved in the industry, some of us on this call, but we certainly are attending the events where that rigging is, and those riggers are highly qualified and constantly looking for ways to get points and attend seminars. So that's something we should look into, and definitely moving forward, I've already gotten calls from our corporate office saying, hey, let's do that, let's look into it and offer those. So that's something we're going to look into for future and certainly try to offer that to our customers.
Great. Okay, another question has come in. Does a wire rope symbol help with the DD reduction ratios?
It helps. Let's put it this way: the wire rope symbols aren't rated. They're more to help with wear and abrasion and things of that nature. But you still need to adhere. They're not rated. I agree. They probably would help to some degree, but you still need to adhere to the D to D ratios for proper lifting.
Okay. Okay. All right. Another question. We're going to take a few more. Let's see. Dropped shackles. What concerns for damage that cannot be visually inspected? What limits are there?
Well, you can do a mag particle if you're concerned. If you drop the shackle and you're concerned that he's probably talking about an internal stress or a fracture internally that maybe you can't see with the naked eye. In that case, you're looking at a kind of more non-destructive testing, but mag particle testing may reveal that. I mean, some people have gone as far as X-rays and things of that. These are not these are beyond the scope of any standard inspection. So there's nothing in the standards that are written that requires that or says, hey, if in the event you drop the shackle, you shall have this type of testing. None of that is written. But I agree. Some of these shackles can get quite large. Shackles that you could walk through. That's how big they get. And yeah, if you drop one, yeah, you certainly want to. I would say it's a judgmental call, and I agree. I would probably want to have those looked at as far, do a mag particle X-ray or something to that nature, knowing that happened, and take the extra steps to be sure that it's still safe. So hopefully I answered that question properly. But yeah. But there's no standard or something that demands that. But it's a great question because certainly if something gets dropped from a high height, you could have did some damage to it, certainly.
Okay. We have just a couple more questions we'll take, and then we'll wrap up for today because we want to make sure we don't exceed our allotted time today. Are there concerns about having shackles painted?
The only, we do have shackles painted by the, we paint shackles. We have painted shackles, galvanized shackles, and self-colored shackles. My only concern before you would paint a shackle that you thoroughly inspect it to be sure that there are no, nicks or anything that that the paint could possibly hide. But with that, other than that, I would not lay the paint on thick. As light of a coating of paint as you could. I'm sure they want to keep them painted for outdoor use so they don't rust, and that's probably a good practice to do. But anytime before you paint something, you want to thoroughly inspect it and pass the shackle and inspection, and then I would then send them out for paint or go ahead and paint them. But don't go crazy with the paint. That you do want the paint to flake off and for visually inspection, so that brings up areas of nicks, gouges. If you do too good of a paint job where it's too thick, you definitely hide something.
Okay, we're going to take just two more questions. And like I said, the rest, Peter can respond directly to you individually. Is a stout zip tie a reasonable mouse option?
It all depends. It all depends. I mean, we would do, obviously wire would be the best, but a zip tie could work. But I would regularly check it, that would prevent it from backing off, and then you could probably easily see if the zip tie has broken. So I would, if you can do a visual of that mouse tail, and it's, you can see that it's twisted out of place and things of that nature. Again, we do recommend a steel wire, but something's better than nothing. Again, there's no standard that would say you have to use this certain type. It just, other than if put in a position longer than the lift or something of that nature, that you should secure the pin to the body to prevent movement of the pin.
Okay, very good. All right, we're going to, as I said, we will take the final questions individually via email, but at this point we're going to wrap up. I just wanted to highlight a couple things before we go. First of all, we have a couple quick polling questions, and we just wanted to get a little bit of feedback from all of you. Just 1 second here. We just wanted to get a little bit of feedback from all of you on how you heard about our webinar. We've been using a variety of different means to communicate with you, and we'd love to find out how you heard about this and which of our methods are the most effective. Excellent. Thank you so much. We love to see that. Great. We appreciate that very much. It's about what I suspected, so that's excellent. Very good. As you're continuing to vote, we have one more quick polling question. All right. I'm going to close this poll, and I will do the next one. Whoops. I'm sorry here. Okay. Are you interested in taking a hands-on rigging class? Peter has referred to a few the offering we have for the next few months, for the rest of the year. So if you could please vote there and let us know. We'd love to see your input.
And as they're voting on that, Gisela, I do want to say these are little tidbits of subjects that we do during our rigging training and that we're doing these webinars on. Like the next one is the lever tool. We're trying to throw these little tidbits out there to show people that, hey, there's a lot to rigging. And I just talked 40 minutes just on a shackle, and really at a fast speed. And just now let's go apply it. Let's try a different scenario so you can see how much time you can spend just on a shackle. So, rigging training is pretty extensive, and really it's tough to do a good rigging training in one day. Really, a 3-day hands-on rigging training is the best way to go.
Okay. Everyone, thank you very much. Just a quick thing, and thanks for the feedback, Gregory. A couple points came up about the zip ties, Peter, and I just thought we better mention these before we wrap up.
Yep.
I'll go ahead and close that. The point was I wouldn't use a zip tie in an outdoor application, and Brian also said that zip ties are rated but cannot be exposed to sunlight for too long. I don't know if you want to just add another quick note.
No, that's great information, and I'll read right from the spec what it reads. It says, for long-term installations, bolt-type shackles should be used. If screw-pin type shackles are used, the pin shall be secured from rotating or loosening, and that's all the standard says. So what you use, again, there's nothing to say what you can and can't use. So I probably had Brian Sickles from the entertainment industry, who is an ETP certified rigger who has extensive knowledge in outdoor rigging, and so that you're also hearing from an expert there that, hey, there are some drawbacks for using zip ties. Yeah, they're convenient, and that's why I said I do recommend steel is your best. A steel wire is your best bet, but something's better than nothing, and there's really nothing to. There's really no standard. It's best practice, is what I always preach. But Brian,
sure.
thank you for that information, and yeah, that's great information.
Okay, and like I said,
so there you go, like zip ties, right? Rated zip ties.
Yeah.
There's more. I mean, there's more to rigging than you think.
Yeah.
Really, are zip ties rated? Yeah, it is. There's things to look for.
Well, and like I said, just to wrap up today, we really appreciate your time, but we wanted to also highlight a couple things. We do have a blog where Peter is one of our main writers, but we actually have 20 authors all throughout our corporation writing on safety, material handling, and all the various things, applications, things that will help you on the job. We also have two Twitter handles. We have one, CMCO Live, and one for our entertainment group. We're on Facebook. Just look up Columbus McKinnon Corporation. We'd love to connect with you there. After this session, since it is recorded, we will be posting it on our YouTube channel, and we'll be sending all of you a link to that. You can find us at Columbus McKinnon. We also have a LinkedIn corporate page if you'd like to have some updates there. Or last but not least, we're also on Google+. So again, thank you so much for attending. We appreciate it. And if any of you have feedback about our presentation, we'd love to have it. You can, Peter, if you can go back to our contact page, I would appreciate it. Please go ahead and send us some feedback to either Peter or myself. We'd love to hear it. And,
yeah, you check out that blog for the shock loading. It's very interesting. And it's on our blog page.
There we are. Perfect. So feel free to send us some feedback